Hey everybody, David over at Frequency Frontiers. So for today's Ham Radio Minute, we're going to start a little small series on RF and some of the problems and some of the things people don't talk about RF when they're building antennas. So today's going to be a little more numbers and a little less folklore. So I'm just going to walk through a few real RF examples. So let's start with a real scenario. On the slide, you see the assumption 100 watts going into a feed point that sits around 3,000 ohms. That kind of impedance is normal at certain levels on HF because of standing waves. The formula is right there. So it's voltage equals square root of power times resistance. So we take the square root times 100 times 3,000. That's a square root of 300,000, which is about 548 volts RMS. But remember, RF isn't DC. So we care about the peaks. Peaks equals RMS times 1.414, which gives roughly 775 volts peak. And that's before any transformer or mismatch multiplication. With real world effects, terminals can climb past 1.5 kilovolts. That is not magic. This is just the E field at work. This slide reminds us of the relationship many people forget. Power equals volts times impedance. Watts are only the product. If a system is at a high impedance node, the current drops and voltage rises to keep the watts the same. That's why saying it's only 100 watts tells you nothing about your shock risk. Voltage defines as whether RF arcs, whether you get carbon tracks, or whether your skin gets burned. So what are some of the real world risks? Let's look at them. Thousands of volts can arc across connectors, especially in the rain. Carbon track cheap plastic, cause instant RF burns, ride the outside of coax shields, and getting a microphone and USB audio gear, especially if you have your HF rig hooked up via USB to your laptop. So if you're a creator, or if you run FT8 digital modes with your rig hooked up through USB like I do, that last one matters. RF in the shack or your studio is always a return voltage problem. It's not a radio problem, a laptop problem, or an OBS problem. So some responsible practices should be, so what can we do about it? So keep your feed points out of reach. Picnic table height is not engineering. Use proper RF insulation. Random Amazon project boxes are not rated for kilovolt use. Add strain relief so gaps don't change and start arcing. Treat grounding and counterpoise as part of the design, not an optional tradition. If you respect these 4 lines on the slide, you remove 90% of the surprises people blame on ghosts or bad coax or the radio. So, the final message. Low current does not mean harmless. Understand the electric field. Explain it with numbers, not tradition. Alright guys, so once again, it's David over Frequency and Frontiers. I appreciate you watching. Stay tuned for part 2. And as always, like, comment, subscribe, share, 7-3.